Measuring Rates worksheet higher. The warm-up activity is filling in the blanks. So from these keywords, complete the sentences. So the rate of reaction can be measured by dividing the amount of reactants used up or the amount of products formed by time taken. And then to find the rate at a particular time from a graph, you have to draw a tangent at that point and then find the gradient of that tangent. Question 1. To find the rate of reaction, you need to take measurements. Which of the following could you take measurements of to work out the rate of reaction? So make sure you tick 2 boxes. So we're going to definitely measure the mass. It could be the mass gained or the mass lost. And the volume of gas produced would be another one you could measure. The volume of a solution would be useless. The concentration might change but not the volume. And frequency, that could possibly link to the frequency of collisions, but it's not something you're going to be able to measure. So if we look at this reaction now, we are going to produce a precipitate in a conical flask and it will go cloudy, and we're going to measure the time it takes. So this is about the experiment, but also there's some key terms about experiments you need to know. So the first part is, what is the dependent variable for this experiment? So the dependent variable is the thing that you measure. So in this case it's the time it takes for the solution to go cloudy. The next one is, what is the independent variable? Now independent is the thing that you change, so that's the temperature, because you're changing the temperature of the solution for the different reactions. And suggest one variable that could be controlled in this experiment to make it a fair test. So control variables are things you keep the same, and here we're going to keep the concentration of the reactants the same. 2.4. The reaction also produces a gas. State whether it would be more accurate to measure the rate of reaction by timing how long it takes for the solution to go cloudy, or by timing how long it takes a volume of gas to be produced. Explain your answer. Well, the volume of gas is going to be much more accurate, and that's because it's a precise point you're looking for, whereas when it's going cloudy, someone might think it's gone cloudy, somebody thinks it's not quite gone cloudy. It's much more subjective. Question 3, we've got some data about a reaction, and 3.1 says, first of all, name a piece of equipment that could be used to measure the volume of gas produced. Well, that's going to be a gas syringe. And then the next bit is asking you to plot data on this table and then draw a line of best fit onto the graph. Now I apologise for the state of this line. Trying to get one done with my graphics tablet is not very easy at all, but make sure you got the points accurately plotted and then that you join them up in a line of best fit, trying to get a curve. So now, referring back to the graph on the previous page, at what time does the reaction stop according to your graph? I put 240 seconds, but it can be anywhere between 210 and 240 if you've drawn it neatly. Remember that this was far from neat. Calculate the mean rate of reaction, so it is the amount of product divided by the time taken. So I get that as 0.075, and the mark scheme would allow anything between 0.075 and 0.086, so just check you got in between those answers. And then suggest how you could check whether the results are repeatable. Well, that's really straightforward. It's repeat using the same method and check that you get the same results. So as a class, everybody could follow that method and make sure you got the same one. If you do, then it is repeatable. Question 4. The rate of reaction between two solutions was investigated by monitoring the amount of one of the reactants, A, at regular intervals. So here we have the graph. So we've got the amount of A in moles and the time taken over time. Here we can see that the amount of A is falling. So the question says, calculate the rate of reaction at 50 seconds after the start of the reaction. Give this rate to two significant figures. Include units in your answer. So here we have 50 seconds, so we want to know the rate at 50. So to get the rate at 50 seconds, we have to draw a tangent. So this red line I've drawn here is what we think the slope is at this point here. So it has to have the gap similar there as it is here. And when we measured that, we found out that we've got through 0.97 moles of the substance A, and it's taken about 153 seconds. So it's a 0.97 divided by 153, which is going to give me this value here, 0.0063 in here. And the units, well, we're dividing moles there for the top one by time in seconds for this one. So it's moles divided by second which gives us moles per second. Using the same graph from last time, we're going to say in the same way, calculate the rate of reaction exactly 200 seconds after the start of the reaction. So here I've got a copy of the graph from the last page, and at 200 seconds we have to draw another tangent, so that's that one there, and I've got that as 0.45 is the amount of substance left over, divided by the time, which I got us to be about 340 seconds. So that divided by that gives us 0.0013. So the tangent is the same as the one on the previous page, and that gives me 0.0013 for the rate, and the units are still the same as moles per second. Now you could get anything in that range for that answer, and yours will probably be a lot better drawn than mine was. And 4.3, the final question, describe and explain with reference to collision theory how the rate changes during this reaction. So as the concentration falls, so as we're using up reactants, the concentration of A is falling, therefore there'll be fewer collisions because there's not as many particles around to bang into other ones, so the rate will fall.